Awesome. Can everyone hear me okay? At the back? Awesome. How are we all doing? Good. Thanks so much for coming to this session. This is actually going to be a jam-packed session. We've got about 40 minutes here, so I am just going to dive straight in. So the adoption of event-driven architecture is growing, right? I've been in the community for a few years, doing open source work, and also speaking to many AWS customers. And event-driven architecture's word keeps coming up, and people kind of keep using it. And the question is why? Why do we have this influx of event-driven architectures? Because when you actually go back into where kind of EDA come from, it's actually older than me, right? So it's actually kind of go back decades and decades, and event-driven architecture really isn't anything new. So why have we seen it? It's because I believe that event-driven architectures are actually becoming more accessible to us. So example here, we have Lambda. Is anyone using Lambda in the room? Cool, so it's about 90% of the room, I think. So we have the compute, right? The AWS compute, where we can actually do some compute based on some particular events. Now, if we link this to API Gateway, is any API Gateway users here? Cool, awesome. So we can actually, this might be a HTTP event, right? So HTTP comes in and we do some kind of compute. DynamoDB using streams, being able to listen to events, right? Being able to listen to things that are deleted or updated and actually be able to react to these downstream and do something with it. Anyone using EventBridge? Cool. So EventBridge, I'm biased, it's one of my favorite services. So you actually be able to publish events to downstream consumers and notify downstream consumers that things are happening. And the thing is, when you adopt event-driven architectures, it's actually an interesting kind of paradigm that happens. There's much more to it than having a producer and a consumer. Are we event-driven just because we have that? I'm not sure. So what does this event-driven architecture journey look like? And it looks something like this. Is at the peaks of the journey, when we get to the top of this thing, we are promised these things, like a decoupled architecture. Okay, this loosely coupled system, being able to evolve our systems. We've read about it, we've learned about it, we talked to our colleagues about it. This is the stuff that we want, so we start to implement an event-driven solution. Now, what tends to happen along the way, that maybe we don't often talk about, is these things. Being actually coupled through contracts and having this asynchronous versus synchronous kind of thinking. As you can see here in this unclear boundaries and this context along the way. So that's what we're going to be talking about in this talk, actually. We're going to go through three main stages of event architectures. We're going to be talking about their benefits and that initial design. Where do we begin when we start? We look at the implementation phase, so when we actually decide to build it, where can we start? What patterns, what services can we use? And then finally, something, again, often skipped in the EDA world is this operational and maintenance stage around schemas, around documentation, and how these things can help. And then summary, and everything I talk about, there's loads of resources at the end, so you can dive deep yourself. And before we start, I introduce myself. I am Dave Boyne. I'm a senior developer advocate at AWS. Been here for about 18 months, primarily focused on serverless and event-driven architectures. Before that, I was kind of doing open source full time around the EDA kind of ecosystem and kind of worked in enterprises and small startups and various things like that. And now I get to come to lovely Manchester and kind of evangelize this stuff. So my job here today is actually to navigate you through this talk and navigate you through this journey. And we're going to start with this, which is the benefits and the initial design. Where do we begin? Now, there's a great analogy when we're thinking about events and we're thinking about state that I love to talk about, which is this. So why do we care about events? Because events tell a story, okay? And the state tells us where we are right now. So if you were to query me right now, which is super weird when I say it, but if you were to query me and ask me where I am, I'm in Manchester right now doing this talk. When we build applications, we have APIs to get the state and display some state to the user. What is the current state of the user? What's the current state of the order? This kind of thing. This is useful. Now, typically, every organization I've worked with, definitely in the past, are interested in events. How did the users get here? How did Dave get to Manchester? Did he get the train? Someone thought I flew here. I live in Peterborough, by the way. It's like 3 hours away. So flying here would take longer. But anyway, So how did I get here? What did I eat last night? Where did I go? I had an Indian last night, actually. The naan bread was huge, the size of my body, which was weird. But your organizations care about this stuff, care about events. And when we dive deep into EDA, why do we care about EDA? Because it can provide some benefits, right? It can provide this loosely coupled system where we can actually say, okay, this boundary over here, this domain, this microservice can actually talk to something else using events and have that decoupled system. We have customers being able to kind of have this super agility, being able to actually use events and actually have this evolutionary architecture, right? Your organizations and every organization kind of changes and adapts. So as new teams come on, you can kind of consume these things. And the big question is, if you're starting with event-driven architectures, where do you actually begin? And I've kind of distilled this in two ways. And I've personally done both of these. And we can take a shortcut, right? We can actually just take a shortcut across here and start with the implementation phase. Or we can actually understand the behavior. And I'm going to tell you first about the implementation phase. Now, when you start building event-driven architectures, this tends to happen. There's actually an immediate value that you tend to get. You're raising an event, you're consuming an event, and you just kind of keep going. And this is exactly it. We have the first producers and the first consumers, and over time, as you can see here, we add more and we add more. But the interesting thing is this value kind of plateaus over time as we add more and more producers and more consumers. And it's an interesting paradigm because when we map the complexity on top of this, the complexity of EDA kind of goes through the roof over time. And that's genuinely because we have more producers, more consumers, assumptions are made, lack of documentation, lack of schemas, lack of standards, and it's kind of this whole kind of YOLO thing going on. So talking about YOLO, this is an example of this complexity growth. Okay, so we have a basic architecture here. We have an order service. And as you can see, we have the invoice and fulfillment things. We have some domains and we have an event, a bus in the middle. Now, we are tasked to notify someone that something happened, right? A fact, an immutable fact that happens, so we decide to create the order created event. Now, if you use EventBridge, you've probably seen this payload before, but if you haven't, let's quickly step through this. So the top, you can see here, we have the detail type. Okay, so the detail type will be that the order has been created. It's the name of the event. Now, if you're creating events, you kind of want this to have a clear kind of intent, right? So someone downstream can actually try and understand what's going on. So we have the order created event. Next, we have the source, which is kind of, think about the source as the domain, right? So my app orders could be the domain of this event. Then down here, we decide to create the detail. Now, the detail is up to you. You can put information in here. You can put the structure in here. So here, we put the order ID and the user ID, right? This is great. We get immediate value from our consumers. Everyone is happy. Now, a week later, 2 months later, whatever it is, sometime in the future, we get another requirement to create an event called the order cancelled event. What tends to happen here is, it might be the same team, might be a different team, but we're in the YOLO event kind of pattern here. So we decide just to create and publish whatever we want. So we start with a reason. Why was the order cancelled? Well, because it was no longer needed. So the consumer can kind of understand maybe some things to do with that. Here we have the type TW. Does anyone know what TW, when an order has been cancelled? Literally no one. I have no idea. I created the slide. But what you see here is actually the implementation details of that context. That order is actually exposed for the event. Okay? So TW, no one has a clue. Down here we have the user. Right? Well, we had the user in the order created event, but we had a user ID earlier. But now we actually have the ID, and we have the first name and last name. Now, some compliance people in the room, this might be PII information. Can you actually expose this information downstream? But the user information here is different. And then what tends to happen over time, we add more events, the order has been updated, and in fact, we have more domains and more events and more buses or whatever else might happen. And you kind of end up in this philosophy where we just kind of raise an event. And this starts to introduce problems. Talking about problems, another interesting problem that you might have is this unclear domain language, right? So I'll give you an example. I worked insurance company before, and I was in charge of the development team, and we talked to the insurer and the underwriter. So we had a user has a policy, right, an insurance policy. So for us, we would consider this policy as something the user has. So we create the event, we create our domain models in this language that we assume that everyone understood. Then what happens is the insurer comes along when we start to integrate using events or messages. They start to come along and say, well, in fact, actually, the policy belongs to us, and the user so happens to be part of that. So we got like conflicting models here. And then the underwriter comes along, YOLO at the end, and just says, no, it's completely different. The policy is completely different. So when you start implementing first, you start to have these unclear domain kind of models leaking everywhere. And it's interesting because it's actually often, this is a quote here by the author of Event Storming, Alberto, but it's the developer's misunderstanding that actually gets released into production. And talking about understanding is this part. It's actually what happens if we flip it on its head and actually understand the behavior of our system before we dive deep into EDA. And what I mean by that is doing some things like this. Understanding the system, okay? The best engineers I've ever worked with, ever, understood the domain and the system and could code that, right? Have that kind of cross between them. Actually collaborating with domain experts. So maybe it's not just coders, maybe it's your product owners, your CTOs, your CEOs, whatever that might look like. Identify events is actually quite a challenging thing to do, okay? And then also that ubiquitous language. Like what language are we going to use in our organizations when we're talking about events, we're talking about messages, and talking about communication between domains? And this leads to a thing you can do, kind of implementation here, event storming. Has anyone done event storming or doing event storming? Cool, so about 1/10 of the room, I'd say. So event storming, what this allows you to do is actually get some post-it notes out and actually model your domain and your events in a room together. Now this isn't just the technical people in the room. As I said, you want to get the domain experts in the room. So you want to get the people that understand the domain and start talking about the events, talking about the aggregates, talking about everything around this. Here's a car park example that I did last year. And as you can see, as you kind of go into the car park, we have a ticket machine. The ticket machine is responsible for creating this, we call it a command, okay? So we create a new ticket. From that, we have the ticket has been created, and then from that, we raise events. Now, I've run workshops in the past. The interesting thing with Event Storm is you start to kind of not argue, like discuss about the events. We're talking about the events. We're talking about the intent and everything around that. And if you do this kind of model, it can really help you build your event-driven architectures versus just diving straight in. So I recommend having a look there. So next here we have the implementation phase. So we know our events, we know our aggregates, we might know our domains. We want to kind of get started. So where and how do we get started? And there's a couple of things to really think about that can kind of help you when you're building event-driven architectures. Is actually thinking asynchronously helps. So here on the left, we have like a synchronous command, right? Your application will have synchronous commands. So something comes in, talks to an API. That API maybe talks to something else, as you can see here, another service. We're waiting for this response to come back to the user. So a prime example of that is like you're placing an order and you're waiting for something to happen and kind of get a response back. Asynchronous events, on the other hand, is kind of like stuff that happens in the background, right? So think about when you order on Amazon as an example, you get the acknowledgement that your order has been created. Thank you very much, the payment is taken. But we have this whole asynchronous stuff going on in the background that happens without you kind of knowing and maybe not caring unless there's some kind of failure. So, and when you model these events and model these asynchronous processes in real life, we're actually surrounded by a lot of asynchronous processes. And then when you map this back to EDA, there's this kind of coupling, not direct coupling. There's an interesting kind of paradigm here. And when you start diving deep into like event-driven architectures, you'll see the words kind of commands and events come up. Now commands, what we do here is we kind of represent the intent. Okay, as you can see here, we have place order. So we're trying to place an order from a user's point of view. This could be a synchronous request. Commands can be rejected, okay, so validation or whatever reason, whatever happened there. And then here on the right, the order service can also accept the place order command and actually raise an event from it using the bus. And it's important to know that events tend to be kind of immutable facts of information that have happened. So the event has been placed, the order has been placed. This is a thing. And then when you're talking about implementation of EDA and architectures, when you kind of dive deep into this thing, as I said earlier, there's more to it than just the producers and consumers. Top left over here, we have like messaging patterns. So point-to-point communications between A and B. We have like pub-sub patterns, being able to notify downstream consumers that things have happened. We also have event streaming, so unbounded data. Data is just constantly happening. How do we manage that and how do we listen to this? Once you go into this paradigm and and implement these things, down in the bottom right, you might come across certain problems, certain things that might happen. So you might want to start looking at some things like integration patterns. And that's what we're going to be talking about next, is actually diving deeper into these things here. So the first thing is about integration. And as you can see here, we have the order service and the fulfillment service. So we are tasked to integrate the order service with the fulfillment service, and we decide to do this just a direct communication. We can do this, right? There's an API maybe exposed to us. We can kind of communicate between these services. Now, when we think about that, we think about, well, what can go wrong with this? You can see here on the left, we have the order service knows too much. Okay, should the order service really know about these consumers in this API? Maybe, maybe not. Down on the right here, we have processing at the same rate. So Black Friday might happen, for example, and the order service, we're getting loads of orders in. We take down the fulfillment service because maybe it's a third-party service. And then that whole request chain breaks. And the users kind of get that kind of feedback there. And again, as I said down there, what happens if that fulfillment service fails? How can we manage this? Now, when we're talking about messaging patterns and talking about event architectures, here, for example, would be implementing something like a queue. Okay, so we can put messages onto the queue, and then the downstream consumer can actually kind of process them at the rate they want to process them at. This decouples the order from the fulfillment service because we can just process orders, put them onto the queue, and kind of process this downstream. And again, we have isolated failures because we can take these messages that fail, put them on something like a dead letter queue, and kind of reprocess them at a future date. And what we're talking about here is the asynchronous kind of point-to-point messaging. Okay, so we have A and we have B. Now the great thing here is when we have B is we can actually kind of scale the consumers. So an example of that would be when I go Christmas shopping, right? Has anyone got kids here? Yeah, a few nods, a few hands. Right, chaos, right, when you're Christmas shopping. So I'm queued up, I'm always too late to the shops. And then you have the tills, right? And why is there only one or two people on the tills? I do not know. And I've got my bags of stuff. The queue's going, I'm stressing out. But luckily, if you're lucky enough, they open up more cashiers at the checkout, right? So they're processing the queue faster. That's exactly what happens here when we're processing the queues. We can actually add more and more consumers to kind of do that. And then when we map this back to AWS, of course, what I'm talking about here is SQS. Okay, is anyone using SQS? Yeah, nice. So kind of fully managed message queue, kind of almost scale infinitely, actually. So the numbers of messages you can put on this is incredible. And kind of we support standard and FIFO queues, right? So ordering of messages. So once you have queues, and your application might have queues and probably will have queues, it looks like the room here have a lot of queues, is what happens next and what other patterns can we look at? So we have the order service now wants to notify things that something has happened, okay? The order service really doesn't care about the relationship, I guess, with these services, but they need to somehow communicate. Now, again, we can do that. If we wanted to, we could do that just implementing this inside the order service and actually going to things and kind of telling them. But again, there's kind of this duplication of effort here. And again, the order service knows too much. So when we had more services in the future that come along, we kind of have to implement this in the order service. So of course, what we do here is actually we go back to the event broker, this pub-sub pattern, where we can actually take an event, the order has been created, and we just push that onto the event bus. And then the event bus, and then the consumers can just consume this stuff without the order service really caring. And of course, here is an example of that. We have the sender sending, as you can see here, the blue and purple, and the consumers can actually kind of decide what they want to pick up off the event using particular patterns. So here at the top we go for blue, and then down at the bottom here we go for purple. So the interesting thing about messages and the pub-sub pattern is the pub-sub, we're actually pushing to downstream consumers something has happened. Messages, we're kind of pulling off the queue to process them. And then when we link this back to AWS again, we're talking about Event Bridge. Being able to create rules for our events, being able to target over 28 different services here and kind of react to these events. One cool pattern that I like to see and like to kind of use too is kind of, is anyone using API destinations with Event Bridge? Okay, no one? Interesting. Oh, a couple of hands, yeah, cool. So actually being able to actually take the events off Event Bridge and actually kind of push them into other services using API destinations. This could be a legacy system, or it could be another system there. So again, talking about flow of events, talking about where your events are in your architectures is actually kind of where the events come from and kind of pushing them out into different APIs. So that leaves us with streaming. Okay, so streaming, when we're building event architectures, you will probably come across streaming. Be able to process this unbounded data is completely different to an order-created event. An example of a stream would be something like clickstream on your website. You want to know where people are dropping off as an example. So we have these clicks, we have like these things happening, maybe putting them into a Firehose, Kinesis Firehose there to process them. Very popular pattern is, we call it kind of change data capture, being able to actually listen to changes in a database and react to them, which is super powerful, because then what we can do is actually say, okay, I want to put something in, I want to update or delete or insert some information, and then we want to do something off the back of that. I mean, you can use DynamoDB streams to do this. Okay, so super powerful patterns when we're talking about event architectures. So we have messages and streams and pub-sub, and your architectures, if you're diving into EDA, will have this. So what else, what kind of problems that might come up, and how can integration patterns help us? So here's an interesting pattern and a story that I had once. We were implementing this EDA architecture in a startup that I was in, and I remember coming in one day and one of the engineers was saying to me, "We've gone viral." Okay, and I was super excited. Startup going viral, cool, look at all this traffic. So our logs, you could see all this information happening, but what we kind of realized as we kind of dove deep is we have more consumers of our events. Now this goes back to sparse events and event carry state transfer, what the type of events. But what was happening here is we'd actually raise an event downstream. There was not enough information in the event for someone to actually do something useful with it. So what they would do is just go back to the producer or an API and just say, can you please give me the order information? Now from a consumer point of view, that might be okay, but holistically, as you can see, the order service just gets bombarded with all these requests. And that's what happened with us. So how can we solve that? What patterns, what integration patterns do we have to be able to solve that? An example here is like the content enricher pattern. So what we can do is we can keep the producer simple in contract, because it all comes down to contracts and maintaining these things, and have the consumer get the information that they need. But what we can do is add some middleware in the middle to actually enrich this information, okay? And that's what all this content enricher pattern does. Now talking again, linking this back to AWS, is anyone using pipes, Event Bridge pipes? Cool, a few people, awesome. So Pipes was launched, we launched this at reInvent last year. This is a point-to-point messaging service, okay? On the left, we can connect these sources to the things on the right, the targets on the right. So you could have a very popular one actually is like DynamoDB to Event Bridge, DynamoDB to SNS as an example. So we can start creating these different kind of point-to-point systems. And then in the middle, the bit I like the most, to be honest, is being able to enrich this stuff and filter the messages. It's the enrichment, so you get information from DynamoDB, you want to enrich it into a third-party system or your own internal system. We can do that using Lambda, you can do that using step functions or API gateway, enrich the information and pass that on to the downstream service. So again, there's an example here of some enrichment pattern. Here we have processing large messages, okay? So depending on what broker you use or queue system you use, there are limits in the payload sizes that you can send. Now, sometimes you might want to send large messages or large events. So how do we do that? And there are patterns, again, to help you with this. This one's called the claim check pattern. So what we do is we actually store first, we get the key back, and then the consumer downstream can actually use that key to receive the information. An example with this would be like storing the information in Dynamo or S3, and the consumer goes and collects the information when they're done processing. Now, of course, with many of these patterns, there are downsides and trade-offs to think about. So here, the consumer would have to know and have access to the bucket or the DynamoDB table, as an example there, to get the information. So these are the things we've got to consider when we use these patterns. Another thing, personal favorite of mine too, is actually understanding the coupling between contracts. Now, when we look into a Leaf into domain-driven design book, that's what we're talking about here is bounded context mappings. Now, if you're using messages or using EventBridge or Event Bus, no doubt you will probably be doing this, which is the conformist pattern, okay? I was doing this for years before I actually realized some of these things. Now, the conformist pattern actually takes the event as it is and you do something with it. Okay, so the order service and fulfillment service. Order has been created, fulfillment says, thank you very much, I'm going to do something with this information, and now I'm actually bound to your contract, I'm bound to your model, I'm bound to your implementation details. Things to consider. So what other things do we have here? We have anti-corruption layers, right? So as events come in, we can actually map them into a domain language, domain model that we understand as a consumer. So we kind of mitigate that risk, change it, and kind of pull that back. Or you go for something else, like an open host service, where you agree with the publisher what language you're going to publish. So the order created event was actually agreed on all of us, and you're going to publish this information, and it's the producer's responsibility to maintain this. And there are other bounded contexts, there are other context mappings you might want to look and consider. But it's interesting with event-driven architectures because, as I was saying, it's very easy to do the conformist, but you've kind of got to be careful here. And then with EDA in general is just a collection of patterns. Okay, there's a great book here by Gregor Hope, one of our colleagues. And has anyone read this book, by the way? Cool, a few people, yeah. Over 20 years old, right, this book, but still relevant today about messaging patterns, about content enricher and all these kind of things. So if you want to dive deeper, I really recommend looking into this. So you talk about messaging, we're talking about queues, we're talking about streams, we've implemented this stuff, we're talking about implementation patterns, right? Talking about and kind of where to get started with event storming. So the question is now, how do you get in this operational and maintenance phase? So you're 12 months, or 2 years, or 3 years down the line. And this is a very common area for people to kind of get stuck on. So when you start building event architectures, we feel like we are in this quadrant up here. We have this high agility, right? We have events going around, this kind of low complexity, right? Because we have 1 or 2 events, or 10 events, or maybe 50 events. As time goes on, this kind of moves over to the right a bit because the high complexity is kind of rising as we have more and more events in our system. And down here, we also have this kind of low agility and this high complexity, and we really kind of want to steer away from this. But without operational and maintenance and standards and governance, this is actually really hard to get to. Because there is a saying in EDA, just in general, is that producers should not know about consumers. So you start reading articles and books and things like this, that your producer should not know about consumer. We just raise an event and we are done, okay? And there's a problem with this, and I think it all kind of distills down to this problem, which is we have our EDA application, we have more and more consumers as time goes on, and then we have more event buses, more consumers, more domains, and this thing is kind of growing, right? And the first questions that you'll have, people ask you is like, you know, what events do we have? So you've onboarded a new team, you've hired someone new. People have left, by the way, people that implemented this thing are long gone. So what events do we have? How can we consume this? We've got a new requirement. This thing's meant to be great for us, but where can I find them? What are the payloads of the events? Okay, so what's actually inside of them? And then also, someone somewhere will probably say, who's consuming what? Okay, we want to make a change, a break and change this contract. Who's actually consuming this contract? Because it's an interesting thing, because we say that producers should not know about consumers, and I guess that's right from a technical point of view, but that means we can't actually kind of skip the governance stage. And I'm a super geek on this part. So when we distill the operational maintenance into three main sections, as you can see here, we have standards, discoverability, and then communication. And we're going to dive into these things and give you some answers here. So the first thing here is we're talking about the standards. So when you're building your events and building your messages, again, that detail, as example in EventBridge, is up to you. You can put whatever you want in here within limits. But here is thinking about what kind of standards do you want in your organization? What kind of metadata do you want? This is actually kind of coined by Sheen and the Lego folks doing a lot of EventBridge work. But this kind of pattern's actually kind of become a standard-ish in the EventBridge community. So think about what kind of metadata you want. So correlation IDs, or your own IDs, custom IDs, your own domains. What information can you put in every event in your organization that will help you distill things and debug things, right? And you can do that by creating kind of custom SDKs or whatever that might be. Next thing I'm super kind of passionate about too is event-first thinking, right? So think about when you get a requirement in, when something happens, we tend to go through this linear process of the requirement comes in, if you're lucky enough, you do some designing of your events, and then we implement this. But thinking about this, it kind of needs to change a bit. If you kind of, this evolutionary of your events, your structures, your payloads, is actually kind of identify, yes, that's correct. So, you know, things like event storming or event modeling is another one. We define them, so when we define our events, and then we implement. But it's not like a we stop there. We kind of go back. You have to go back. You have to review your events, review your messages, and just have a look. Someone's got to own this. And if you're interested in diving deep into this, I've done a talk, a 40-minute talk, all about this, if you're interested. Next thing here is about discoverability of your events. So who is doing what, who's consuming what are the payloads, all them kind of questions. So is anyone using schema discovery with EventBridge? One person, cheers. Cool, so schema discovery is an interesting feature. So as events fly through your event bus, you can turn this on and it will try and document these events for you by providing JSON drafts, specification or open API specifications. So again, the order place comes in, EventBridge will manage this, create the schema for you, and then with that schema you can download them through AWS directly or use things like the VS Code plugin to be able to kind of see these events and use them. So it's a great way into discoverability of your events. Another thing here, has anyone heard or using async API? Awesome, a few people. So I was on this team doing some open source work with them for just under a year. Fantastic community, by the way. But async API is a fantastic specification that allows you to document channels, subscriptions, payloads, events, consumers, and producers, right? So take OpenAPI, it was a fork of OpenAPI, and now you can actually use this to do that. Now, the great thing about standards and specifications is we can create tools and communities off this, right? So there are loads of tools, there are a load of bindings if you're using Kafka, using other event buses or messaging topologies, then you can check this out. They have an SNS and SQS bindings happening at the moment. So if you're interested, that's great. And this is a kind of a weird shout out from me, but I am actually super geek and passionate about schemas and documentation. So I created this tool, open source tool, that seems to kind of get in some traction around documenting EDAs using like static websites. So visualizing producers, visualizing consumers, being able to kind of see this and get access to this easily. Because it's an interesting problem space to be in. A lot of people are in this problem space, and a lot of people are still trying to figure it out. So hopefully there are some solutions there that can help you. Here, and at the end, we have the communication part, right? And it's actually understanding that the communication is different between your domains, right? Your domain models, and actually having this public language in the middle and actually understanding that. And as you can see here, we have domain models, and the orders in one service might not necessarily be the orders in the other service. So as we communicate using events and messaging, it's really important to actually understand these differences and these like nuances, and they can kind of help you out there. And I believe because with the standards and the discoverability, we can actually kind of push away from this number 3 and actually kind of move up into number 1. And I think our documentation and this observability and communication piece can kind of just really help you remain there, because this team, I think EDA in general can kind of really provide this high agility stuff, but you kind of got to nurture it and look after it. And with that, I kind of just want to summarize everything we spoke about. At the start, I spoke about that event-driven architecture is a journey that we go on. Okay, so just because we have a producer and a consumer, are we event-driven? Just because we have one queue, are we event-driven? In fact, that event-driven architecture is much more than that when you kind of open up and explore. We spoke about this journey about, at the tops, this benefits of event architectures, this agility, this decoupled, this evolutionary architectures that you can get. I've seen it. I've been on teams before, led teams with this, and it's an agility that I've never seen before. That's why I'm a super geek on the subject and kind of like to evangelize with it, because I think it's pretty awesome patterns to work with. But equally at the bottom, without careful considerations, we can kind of fall into these traps, and we kind of want to try and steer away from these. We spoke about the initial design, the step 1, right? We spoke about events. Why do we care about events? Because our organization cares about events. Events are everywhere. Events actually tell us the story, right? So we capture them events and we can kind of replay them, or we can project them into different views. And that's probably a different talk there. Behavior first and actually do things like event storming can help us really identify our events within our organization, and we can use that to kind of push and implement our architectures. And talking about implementing our architectures, we have these, which is different event types. So remember, we have commands and we have events. Your architecture will have both of these. Being able to push a command on, being able to do this, and then be able to react to events downstream, the facts that have happened. And then we have also messaging patterns like pub sub and the queues that your event architectures will have. Then equally to the side of that, you'll have integration patterns. You'll come across different problems and use cases, but there are integration patterns that might be able to help you here. And then finally there, as I said, EDA really, for me, is just a collection of patterns. And then finally, when you're deep in the subject, talking about operational maintenance, standards, discoverability, documentation, schemas, who's using what, this can actually really help you scale your EDA architectures. Because I can almost guarantee you, once you go along that period, you will have these common questions of who is consuming what, how can I get access to this, and things like that. So documentation can help. We spoke about some serverless services that can help you here. So we talked about SQS, this point-to-point integration using queues. We spoke about Amazon EventBridge, being able to kind of push information out to everyone, in this audience here, and people here can actually kind of consume it if they want to. DynamoDB streams, being able to listen using change data capture patterns, listening to inserts and updates and deletes, super powerful when we combine that with compute and be able to do things. And again, EventBridge pipes being this point-to-point communication system with optional kind of filtering and enriching and connecting more things together in AWS. Has anyone had a coffee from Serverless Espresso yet out here? Cool. So the team I'm on, we built this architecture. It's using step functions, EventBridge, IoT Core, API Gateway, Lambda, all the goodness, and DynamoDB. So if you want to dive deep into a real-world example of an EDA architecture, come grab a coffee, scan the QR code, and there are people around that can kind of walk you through how that works if you're interested. Workshops are online there. And then finally, has anyone used Serverless LAN before? Great, it's about half the room. So we actually maintain, so the team I'm on, we maintain this website. We've got like over 600 serverless patterns. We have over 150 step function workflows. We have new learning resources just come out. We have reInvent content going on there this year. So once the videos are up, I'm going to publish them all on here so you can kind of capture that when you want. So yeah, recommend checking this out if you want to dive deeper. And equally here, everything I talked about in this talk, all the research that I did in this talk is at the top link here. So talk resources on GitHub. And then finally here is EDA visuals that I've been creating throughout the year. So this is like 45, 50 bite-sized visuals that you can learn about event-driven architectures, not necessarily tied to any particular service, but tied to EDA as general. So you can download these all online for free if you're interested there. And with that, I think I'm on time. And I just want to say thank you very much for listening. And if you've got any questions, if you can't get a chance to do it, I'm literally out here, lunchtime. I'm around all day and night. So feel free to come and ask anything you want.